Education. America's school system has been stuck inside the same structure, but that world has begun to change. By embracing the best ideas from a myriad of disciplines, we are transforming the shape of education. Welcome to MASH Ed Up. Reimagine education.
Good afternoon. I was at a meeting this week at NASA Ames, and we were talking about putting a research park on the moon. And the first step might be actually to put robots on the moon and create a robotic village that actually built a village for possible human habitation. In the afternoon during the meeting, which had a number of speakers, an old man slumped over, and an hour later we heard that he had died. And it brought, all of us who were texting and writing and emailing, to a kind of a sudden stop and realizing we were in this particular moment. And it wasn't just that a man had passed away, but it happened to be a man of great achievement. A man with a physics degree, a math degree, a Nobel Prize laureate in medicine who had discovered and come up with a vaccine for hepatitis B. And he did that by traveling in the field, places like the Arctic and the Congo. And he ended up finding it, the antigen, in a population of Aborigines in Australia. At lunch, I met him for the first time, had only a few minutes, and I talked to him about Maker Faire, and his eyes lit up. And he had this very warm smile. And I told him, because he had talked about citizen science and how we needed to include more people and get more people participating in science and in space. And I was telling him about the Maker Faire, and his eyes lit up and he said, I'd really like to see that. And I say that because in the last moments of a great life, you could still see the childish curiosity and exploration. And here he's at a meeting to think about doing things on the moon that won't be realized in his lifetime. So when we see these things in old makers, it becomes even more urgent that we discover them, recognize them, and cultivate them in young makers. And that's what we're here today to talk about. Tony is going to tell you a little bit about a Young Makers program that we just started last year with the Exploratorium at Pixar. And if you've been to Maker Faire, you know we have a lot of kids there. We have a lot of people of all ages there, and they're inspired to make things, to do things. And but what we wanted to be sure is that we were getting kids there as makers, to invite them to participate, to take an idea, as rough as it may be, and put it through a process, meet with other people, think about it, and create something real, and then get up and talk about it and share it with other people. And this year, we're in our second year. We have meetings, including next Saturday at the Exploratorium, where they show their work, and we do a bunch of interesting things. But I think making has this tremendous power to transform education. The great child development psychologist Jean Piaget. I studied him in school, but I didn't know what he had written about education. And I found his book that he wrote in 1973. The subtitle is The Future of Education. The title is To Understand is to Invent. So making isn't just about hands-on activities or getting engaged with your hands. It's actually how we make meaning, how we think, and we construct our world in new ways. So Tony, is director of research at graphic research at Pixar, and he came to us with this idea for young makers, and he can take it from there.
Thanks, Dale. Well, the goal of the Young Makers program is to inspire and develop the next generation of innovators through ambitious hands-on projects of their choosing. And the program is based, at least in part, on my own family's experience. So let me tell you a little of that backstory. I have two boys, Joseph, who's 12, and Sam, who you'll hear from shortly, who's 16. And we all love to build things, so we've developed a family tradition where we pick a design challenge in time to start work over Christmas break. And then we work nights and weekends, sometimes furiously, until we take our creation to Maker Faire. And So our project in 2009 was based on the familiar potato cannon. How many of you know what a potato cannon is? Yeah, it can launch a potato about 400 feet. And we do a lot of brainstorming over dinner, and over dinner one night we wondered if we could make a Gatling gun version. So here's what we came up with. It can fire all 6 barrels in about a minute, or about a second, rather. And you know, working on these open-ended, challenging projects just creates a huge number of teachable moments where we can talk about all kinds of science and technology topics, such as, in this case, mechanical and electrical engineering, chemistry, and physics. And the boys were involved in every aspect of the design and the construction. And then when we got to the fair, I watched as they explained the theory of operation, the details of the build, all the geeky little design trade-offs to tens of thousands of people that stopped by the booth. And as a parent, it's hard to describe how incredible it was to kind of step back and reflect how much they and I had learned through this project. And it made it even more rewarding because we all learned it together. We were solving problems together in the garage. So the Young Makers program is intended to bring this kind of meaningful family experience to other families and to other kids. And the idea is pretty simple. We pair project teams with adult mentors, and the role of the mentor is to help the team find a project vision if they don't already have one, and then help them to realize that vision in time to take it to the fair. And then we meet monthly at the Exploratorium between January and April, and they get to participate in an event called Open Make. The next one is this coming Saturday, where they get to rub shoulders with experienced makers. They get to share their work in progress with other project teams, and they get to hear talks from some really amazing featured makers. Here are a couple of people from our pilot run last year. This is Nathaniel, whose vision was to create this riding, flaming chopper. This is Evan. He and his dad built the Laddervator. It's a container that straps onto a ladder and takes tools and materials up and down for roofing jobs. And this is Colin and Joseph. They built a new kind of skateboard truck that gives them a lot more control, especially at high speed. So we paired them with a mentor that helped them build CAD models and cut their design out of CNC machines. I'm going to turn it over now to Janavi Kalpathy, who was one of the participants last year. And if you want to learn more about the program and how to participate, visit youngmakers.org.
Thank you, Tony. As he mentioned, my name is Janavi Kalpathy. I was a participant last year in the Young Makers pilot program. I teamed up with 2 other girls, Hannah and Pearl, to make this product, which I have here today. It is basically 2 destroyed IKEA tables reinvented to form another table. We then took the legs of the destroyed table and made maze pieces. So our final product basically is a pet habitat / maze on a table, the Habit Table. It was actually pretty interesting that the 3 of us found our way to each other, considering we were all from different grades and from completely opposite ends of the Bay Area. In fact, it may have just been the fact that none of us had testosterone that led us to each other. We were the only 3 girls last year. So it was amazing to see how these 3 different people with different ideas came together to add ideas to our table. Pearl was the designer. She came up with the basic idea and pretty much made the initial designs. I was sort of the engineer, so I did the calculations and came up with the idea to grid magnets on our table so that the maze pieces could be movable. And Hannah was really into arts, so she made our table as aesthetically pleasing as possible. We also had amazing support from the Young Maker mentors, like Joshua Seaver and Tony DeRose, who gave us the confidence, the structure, and the guidance to enable us to succeed. And basically what I've learned from this whole process is that making is just incredible. I've learned that the process of building is the most important part. We had to pretty much imagine, create, build, fail, and try again. And even though in the end our final product isn't very practical or useful, and it's pretty diminutive compared to the roaring Saphira behind me, it was still a success for us because it engaged both the audience and the makers in the process. And when we finally took our hamster and put him in his new home, A regular household coffee table was transformed into an amazing animal terrarium. That's what I learned as the magic of making.
Thank you very much. So, just a question. Talk about frustration or failure. This thing didn't come out right away, did it?
Definitely not. Our initial designs had little gates which would be triggered by motion sensors when the hamster walked over it. It had LED lights and all kinds of crazy technology that we were going to make it fantastic. Then we figured out we were running out of time, we weren't as smart as we thought we were, and a bunch of other things. So basically, we just simplified the whole project down. We figured out what we were able to do, and we were still challenging ourselves because none of us had ever done a project like this before. And we just turned it into something that was manageable and actually came up with a final product rather than trying to overachieve. We also found out that the IKEA tables weren't nearly as sound as we thought they were, so we had a little bit of tinkering to do with that.
Okay, and tell me a little bit about your experience at Maker Faire, just talking to people about this.
Sure. So they had basically a section for young makers set up, which was really cool because all of us who'd been working on our projects together for the past 3 months were in one room. And the people would come through, and like I mentioned before, this project was able to actively engage the audience. Because it was a movable maze and it had a hamster, which everyone loves, everyone was really excited to come over and play with our project, ask us questions. So we got to really show off what we'd learned. It was pretty fun.
Okay, thank you very much.
Thank you.
Our next two young makers, Sam DeRose and Alex Jacobson. Come on out and tell us about Saphira the dragon.
All right, well, this is Saphira. She's an animatronic fire-breathing dragon. And we chose this project for a couple of reasons. One, because it's an animatronic fire-breathing dragon. And who wouldn't want one of those? Also because we like projects that really push our abilities as makers and force us into learning new mediums. And this past year, we knew we wanted to learn how to work with metal and also become more comfortable working with pneumatics. And an animatronic dragon brought those two aspects together really nicely. The project team consisted of myself. I did a lot of the physical and mechanical design. Alex Jacobson did all of the software and the programming side. Our dads mentored us, and one of my dad's coworkers, Sean Neely, helped us out with the flame effects. And my brother was the media director for the entire project, and he made this short promotional video. And now I'm turning it over to Alex.
So as you can see here, we have our basic fire-breathing dragon control station right here with our joystick and our laptop hooked over to our Saphira, the fire-breathing dragon. So one of the first movements we designed was the body lift, which requires that to be on. And then comes the head up and down, the head left, right, the jaw, and then, of course, we have everyone's favorite, the wings. So when you put those together, you get this.
Just to explain briefly how it works, we have a compressor backstage and a pressurized air hose coming in that's split up into a bunch of different solenoid valves. And the valves channel air into about 6 or 7 different air cylinders, which act as the dragon's muscles. And then for the fire, unfortunately we couldn't do it today. We usually have a propane tank back here and a hose that runs up the whole length of the dragon into the head. And we have a spark plug and a transformer. And when we spark the plug, we get about a 10-foot fireball. And if you'd like to see the flame effect and it all put together, come to the Maker Faire.
That's great. So, just a couple of questions. I mean, where did you build this?
In our garage.
In your garage. So, I mean, that's kind of one of the neat things here. We tried this year, even as we expanded it, to try to find places in the neighborhood where kids could get together and build stuff, finding a garage with some useful tools and things. But you learned to weld and some other things during this project that you didn't know how to do before, right?
Yeah, we got a MIG welder and learned how to weld and learned how to use an oxyacetylene torch to cut metal.
Yeah.
Yeah.
And Alex, you did a lot of the programming, and this involved Arduino and some other things as well?
Yeah, so what the computer is hooked up to is what is called an Arduino, which is a microprocessor chip that you can buy from the Maker Shed. And it's really useful and completely open source, and you can build whatever you like on it, including fire-breathing dragon.
Mm-hmm. But it's kind of neat. You guys kind of worked in 2 different ways, but it's one project, and you had to kind of, you end up with something that's pretty creative and unusual, and then you go to Maker Faire and share it with people. Can you talk a bit about what it was like just getting feedback on your project and actually getting it out of the garage and into public?
Yeah, it's always really great going to the fair and just seeing people's reactions because, you work on this thing for 5-6 months and it completely drives you crazy, and the last couple weeks you hate the thing and you want to go to the fair and just leave it dust and want to forget about it. But then you get there and you set it up and you see the look on little kids' faces, but also grown adults when it pops up and blows fire and they all step back, and it's really great.
Yeah. Did you have any snafus or any problems when you were getting it ready for the fair?
Yeah, actually, a lot of the actuation in getting the head to move left and right, especially, we finished that about 12 hours before the fair. We were in the garage working on that late into the night.
Yeah, that's great. How about you? I know you had to learn more about coding than you knew and other things to get this all done.
Yeah, one of the biggest problems we had towards the end was making sure that the computer would work with the Arduino, because we used my computer and then we used Tony's and then we just kept changing it around. And eventually we ended up with Tony's, but the breadboard that was also hooked up to, which is where we connect all the wires together, was also getting messed up, so we ended up duct taping it, and then that solved most of our problems.
Okay, duct tape, a very useful maker tool. Okay, well, guys, thanks a lot. It's a terrific piece of work.
Thank you.
So, and thank you all. I'd say this is still in a kind of a pilot phase, but again, an exploratorium next Saturday. You have kids come there between say 10 and 12, and they can participate in making activities and see some of the projects that the kids are working on. So, thank you very much.